It's Mrs. Black again. Here are some examples of force vector diagrams for objects which are falling. Okay, this first one here is a ball freely falling on the moon. Freely falling means there's no air resistance. So the only force acting on it is the gravitational force on the ball from the moon. So that's it, just one vector down. All right, here's a human just after jumping out of a plane. Okay, the air drag, which is FD, depends on speed. So the human is not fast enough yet for the drag to be equal to the gravitational force. So it's just gravitational force on the human from the earth, and then air drag on the human from the air. Well, you know, over here is a human falling at terminal velocity. Terminal means last. And you can see it still has the same gravitational force on the human from the earth, but now the human has sped up enough so that the drag force on the human from the air is equal in size, opposite direction. These are not action-reaction pairs because this is drag, this is gravitational force. And they're both acting on the human. So they're not action-reaction pairs, but they are equal and opposite in direction. And so what happens is it stops accelerating because, you know, they're canceling each other out. Whereas this one's freely accelerating. This one's accelerating, but the acceleration will gradually get less as this air drag gets larger. Okay, here are 4 more force vector diagrams. Okay, here is box A, dragged at a constant velocity. So obviously there's tension on A from this rope. There's a gravitational force on A from the earth. There's a friction force on A from the floor. Has to be equal to the tension or it wouldn't be at constant velocity. And then there's the normal force on A from the floor upward. So closed figure, constant velocity. Anytime it says constant velocity, has to be closed. Anytime it's accelerating, has to be open. Okay, here's a boat pushed at a constant velocity by a wave. Alright, so haven't written those down yet, but this is the force buoyant on the boat from the water. Okay, here's the force drag on the boat from the water. And here's the force gravitational on the boat from the earth. Okay, so we have those 3. Constant velocity, closed figure. And if you were interested, here's the angle of elevation of the wave. All right, now here's box A at rest on a ramp. At rest is a constant velocity, therefore it must be a closed figure. So from the ramp itself, there's a normal force, squish, squish, pushing up. Gravitational force from the earth pulling down. And a frictional force from the ramp pushing up. Closed figure. And the angle of the ramp always between the normal and the gravitational. Alright, finally, there's a box over here. There's a box pulled at a constant velocity up and over a pulley. Now, whoever is pulling it over here or whatever is pulling it over here is not touching the box. So don't get fooled by this thing. All right, so the things that are touching the box are this string here. That's it. So you have tension force on the box from the rope or string right there, and then the gravitational force on the box from the earth. That's it. This is nothing. This is where it's in contact with the box.